Hi, good morning, everybody. We are going to go over reflections today. So this is one of our transformations. So remember, yesterday we said a reflection was a flip. So what we're doing today is we're taking a shape or a figure, whatever you want to call it, and we're going to reflect it over something called the line of reflection. Why is that white? So we're going to reflect this weird looking shape over here, right? This red guy, and I'm going to flip it over that purple line, which we call as the line of reflection. And it would end up in that blue position. Okay? So these are just some ideas just to kind of get your mind in the right frame of mind. Like there's our night logo, right? And if you notice, like this point here matches this point here. And they're the same distance away from the line of reflection. Right? Does that kind of make sense? Or maybe this is a better image. This C right here and this C right here, they're opposites, and then this distance and this distance are the same away from that line of reflection. Okay, so let's grab out your notes and we'll fill in our notes for reflections, okay? Okay, so reflections. So we said a reflection is a flip, or it flips a figure over a line of reflection. And in order to create a mirror image. Each reflection point of the figure should be the same distance from the line of reflection on the opposite side. So that's kind of what I was saying on that previous slide, right? It flips it so we have a mirror image and they're the same distance away from your line of reflection. So it's not very hard, you guys. It's just kind of more tedious would probably be the word I would describe it. So let's just look at this first one here. It says reflect the figure shown over the y-axis. Record the coordinates of the pre-image and the image. Okay, so let's just talk about a few things here. The y-axis, let's outline that. That's the one that goes up and down. So you guys darken this, highlight this, do something so that you know that this is our line we're going over. This is your y-axis. Okay. And let's start by writing down our ordered pairs. So this is where it gets a little tedious. So if we just go in like alphabetical order, we'll start with D. Where is D at? D is at -7, -4. -7, -4. Okay. E is at -4, +1. And F is at -3, -5. All right, so we've written down our pre-image ordered pairs. And now, how do we figure out where we end up when we reflect? Well, it's quite simple, you guys. We really just count. So if I look here, how far away is point D from my line of reflection? And again, you guys, just count. So here we go. 1, 2, 3, 4, 5, 6, 7. So now I have to go 7 in the opposite direction. 1, 2, 3, 4, 5, 6, 7. So this is where D is. So D prime is at 7, -4. Okay, now I'm going to erase my little counting marks just so it's clean. For my next one. Okay, now let's do E. How far away is E from our line? 1, 2, 3, 4. So now we gotta go 4 the other way. 1, 2, 3, 4. So there's E prime. E prime is at 4, 1. E prime is at 4, 1. And then lastly, F. F looks like it's 1, 2, 3 away. So we gotta go 3 away in the opposite direction. 1, 2, 3. F prime. So F prime should be at 3, -5. And then remember just to connect your dots here. There we go. And if I got rid of all of my little lines here, do it quickly. Do they look like mirror images? Yeah, they should, right? So now it wants us to look. Do we see any patterns? So if we look at our ordered pairs, you guys, do we see any patterns? And it's sometimes tough, right? If we just look at our x value, like our x coordinates, the first number, what happened? You just focus in on the first number. I'm hoping you notice that they all just became the opposite. They became the negative version of themselves. So we can say that x value or the x coordinates becomes opposite sign. Y coordinate, what happened to our y's, you guys? Anything? No, they stayed the same. And why don't you guys write that? Stayed the same. So we have a rule for this. Why don't you guys write this right here? So if we have a rule, you start with x, y, and then to show that the x went the opposite, you put a negative in front. So that's our rule for the y-axis. I'd probably star that. Make sure you write that down. That's really helpful, okay? All right, good work. Okay, let's try another one. This time we're reflecting our figure over the x-axis. So let's highlight that. Highlight your x-axis. That's the one that runs side to side. That's your x-axis. Oops, what am I doing? Spelling x-axis. I wrote axis twice. Silly me. X-axis. Okay, let's start again by labeling our ordered pairs. So if we start with A is at the location of 2, 4. B is at the location 6, 7. And C is at 7, 3. Okay, again, folks, we're just counting. This one's a little bit easier because it's just straight down, right? So how far away is A from our x-axis? I hope you're thinking it's 1, 2, 3, 4 away, right? So now I gotta go 4 in the opposite direction. 1, 2, 3, right here. There's our A prime. So our A prime will be at 2, negative 4. Okay, our B is 7 away from our x-axis. Now we gotta go 7 in the opposite direction. So we're gonna end up at negative 7. B prime is at 6, negative 7. And then our C looks like it's 3 away, so we have to go 3 in the opposite direction, which is right here. Our C prime. So C is at 7, negative 3. Again, we'll connect our dots for our image. And again, they want us to look for patterns. So if we look here at our x-coordinate, we look at our x-coordinates, folks, the first number in our ordered pair. Did anything happen? No, it stayed the same. Now if we look at our y-coordinate, it did become the opposite sign, right? So we had positive numbers and then became negative. So we would say it became the opposite sign. So kind of like we did before, let's put our little rule right here. So if we have an ordered pair x, y, it then becomes x, negative y. That negative y makes it the opposite. So again, star that. Make sure you write that down. That's good stuff right there. Okay, let's flip the page. You can also reflect an image over other vertical and horizontal lines besides the x and y axis. So we're just going to have to review this. You might have talked about this last year in Algebra 1, but I know that was forever ago, so it's a good review right now. But it says a vertical line was written in the form x equals a, where a represents the line's x-intercept. So if you remember what an intercept is, it's where your line goes over either the x or y axis. So if I wanted to graph a line x equals 2, I'm going to go over to 2 on my x-axis and draw a line straight up and down there. That is the line x equals 2. Now, similarly, a horizontal line is written in the form y equals b, where b is the line's y-intercept. If I want to do y equals 2, I'm going to go to 2 on my y-axis and draw a line through that. Okay? You guys see the difference? Okay, so let's try a few of those. Reflect the figure over y equals -1. So again, step 1, y equals -1. We got to highlight that line. So we go to -1 on our y-axis, which is right here, and then draw in our horizontal line. And now, folks, we just count. We're just counting. How far away is a from our line? Here we go. 1, 2, 3, 4, 5. Now go 5 the other way. 1, 2, 3, 4, 5. There's our A prime. Make sure you label it. Okay, let's do our B. B is how many away? 1, 2, 3, 4, 5, 6, 7, 8. Now we gotta go 8 in the opposite direction. 1, 2, 3, 4, 5, 6, 7. Oh, we ran off our page. That's okay. So somewhere right here-ish would be our B prime. And then our C, how many away? 1, 2, 3, 4. Go 4 away. 1, 2, 3, 4. C prime. Clean this up a little bit just so I can kind of see better what's happening when I connect them. All right, you guys, let's see. How did we do? This is what yours looks like? I hope so. All right, next one. Will you guys change it for me? Will you make it x equals -2? Just because otherwise we'll completely go way off our graph if we do it as x equals 2. So again, figure out where x equals -2 on the x-axis is. So that would be right here. Draw in your line. Okay, now I'm going to let you guys get a head start. Pause the video and reflect that triangle over our line of reflection. Go. Okay, check yourself now. I hope you did it. Your F prime should be right there. Your D prime. 1, 2, 3, 4. See, as all it is counting. I have to count 2. 1, 2, 1, 2. There we go. And if you took your piece of paper and tried to fold it on that red line, all of your ordered pairs should line up right on top of each other. So that's like another way to check to make sure that you did it right. All right, last few examples, folks. Thanks for hanging with me. I know it's getting kind of long. All we're doing is drawing in our line of reflection. So our images are already drawn. We have to figure out where it kind of cuts it in half. You kind of want to find the middle of your images. So maybe you want to pause the video and try these on your own. That's okay, because it's kind of hard just to tell you, right? I mean, because like on this one, I see that there. How far away are my B primes? 1, 2, 3, 4, 5, 6. So I know I have to go halfway between 6, which would be 3, right? So if I go 3 away, 1, 2, 3. That would be our line of reflection. And then if we wanted to label it, it'd be x equals, we throw it where? 1. X equals 1. Okay, this next one, it looks like our x-axis right here is our line of reflection, right? That's what's cutting it in half, so we'd say the x-axis. Now this next one's pretty tricky because we have overlapping shapes. But if you look at your T's, I want to be halfway between my two T's there, right? So if I go halfway between my T's, this is where I end up. Do you guys see that? It's kind of crazy. What line is that? X equals 4? Now this last one is pretty challenging. We actually have a diagonal line, and it's just going perfectly diagonal through our origin like this. And that would actually be a line y equals negative x. That's kind of a doozy, but as long as you could draw in that line, like that blue line, we're good to go. Okay, folks, thank you for watching. I appreciate you a lot for doing what you're supposed to, and I will see you tomorrow. Bye.